Hi, good morning everyone. Today I'm going to be presenting some results from all the vehicle emission remote sensing measurements that we've made this year in Leeds, but also we've had a project up in Aberdeen and have kind of pulled together all of that data that I'm presenting today. Now, remote sensing it's quite a neat way of doing it. It does two things. The key things are it firstly gives an understanding of actually what the vehicle fleet is composed of, and then gives a good measure of its emission performance. And coupling those two things together, I think, is a kind of very powerful tool. And I kind of think about it as a bit like a kind of big data approach to assessing vehicle emissions. I'm pragmatic. It isn't as accurate and precise as PEMS data or lab data, but it offers something very different in terms of the sample size and the fact that it can scan the whole operational fleet with all kind of warts and all. And I really kind of see this as a really good tool for verifying emission models. So if our air quality models aren't validated or calibrated to measurements, I've got a transport planning background. If transport models weren't calibrated, they would be terrible in modelling emissions. So I thought today the emphasis of my talk was all going to be about talking about the kind of benefits of Euro 6 vehicles and giving a good assessment of that. Obviously, kind of in a position to also provide some comment on this VW scandal that's happening. And I'm not going to embarrass people by who's driving a kind of a VW or a Seat or a Skoda Euro 5 diesel car, but actually after this talk maybe you might be sitting slightly more comfortable, and that people driving some other brands might be feeling a little bit more nervous. Okay, so for those of you that don't know what kind of remote sensing is, I'm going to give a quick scan through that, but also present some of the work we've been doing to verify the method. So one criticism is it's all smoke and mirrors. Well, I'm kind of going to show some of the verification work that we've been doing with our instrument before presenting results of Euro 6 for firstly cars, but also heavy goods vehicles. I haven't seen any basically vans or buses yet, so I'm not able to, in our data set this year, I'm not able to present any of those, that assessment, because there aren't many on the road yet. Before getting on to kind of the manufacturer comparison. Okay, so here's a picture of us doing some measurements. Actually, this winter up in Leeds, we've been also quite interested to see kind of temperature effects. It is a coincidence that there's a VW Passat in the shot. This was taken in the winter, so it was before everything's unravelled. So this is our instrument kind of scanning across the road. So it's scanning through the exhaust plume of every vehicle as it drives through the station. We're measuring its speed and acceleration with some sensors on the roadway, and there's this camera here that's recording the number plate. From the number plate, we send that data off and we access information on basically all the kind of specification of the vehicle. We don't know anything about the driver. We just know a lot about that vehicle. Everything that's held on the kind of detailed vehicle registration database. Critically, whether it's obviously petrol or diesel, when it was registered, first registered, but also its actual Euro standard. So it's not estimated from the date of registration. It's its actual registered Euro standard. And I'm going to do a little bit of kind of analysis of that a bit later on as well. That's quite informative. Okay, so we've done some verification of kind of the speed and acceleration measurement, so we can get an understanding when we're doing analysis of kind of power and emission performance. How good is this? So we've basically driven a car equipped with a really precision GPS and sensors recording actually the road speed rather than just GPS speed through the system, align those, and basically we've got GPS speed. GPS is on the x-axis, instruments measurement on the y-axis. So, okay, speed, acceleration, And on the right-hand side, those of you that may be kind of looking at technical vehicle emissions, there's a measure called vehicle-specific power. There's an equation here, but basically it's just it's a very good way of describing the power that a vehicle is undertaking, the engine that's generating to overcome speed, rolling resistance, aerodynamic drag, and basically positive VSP. So when a vehicle is accelerating and doing some work, is correlated very well with fuel consumption and CO2 emissions. So that's quite. So we use that metric a lot. So that gives us a lot of confidence that we can apply that data well. We've also verified the kind of the concentration measurements that it's taking by exposing kind of off-road in a garage, in our lab. We've been exposing it to kind of different concentrations of gases from a calibration cylinder, CO, hydrocarbons, and NO. And the manufacturer's reported precision specified error is kind of 15%. So this spike is what we were getting from it measured, and the dotted line is what the kind of the manufacturer's kind of specified performance would be for that kind of concentration. And basically for CO and hydrocarbon, it far exceeds the manufacturer's specified precision. For NO, it's broadly as specified. We also, over the years, have worked a lot with David Carslaw, he has been working with me up in ITS, but he's also of King's and now of Ricardo AEA. And back in 2013, there's one instrument in the world. So our instrument can measure NO, CO, and hydrocarbons. It's kind of more of a kind of commercial instrument that we've had for 8 years now. David Carslaw has imported, there's one instrument in the world that can kind of speciate, there's one instrument in the world that's working that can speciate nitrogen dioxide. And that was brought, and we basically put these instruments together in some kind of off-road tests, testing the performance of different vehicles, doing repeated drive-throughs, and the instruments are they're slightly separated, and they actually use a subtly different way of coming up with these pollutant to CO2 measurement ratios. But when we look at the kind of the NO component of that, the CO2 ratio, we've got a very good correlation between the two instruments, which was it does two things. It allows us to it gives us confidence in the measurements we're taking, but it also means that NO2 fraction estimates from this kind of FEAT more research instrument that's sadly aging. I think its dates kind of mid-80s. We can use the fractions from that to kind of estimate a kind of a Knox emission with our instrument. This is kind of a schematic of the setup on a kind of a single lane. It has to be operated on a single lane, and we want to be ideally on a slight grade so vehicles' engines are under load. A modern diesel vehicle decelerating actually has kind of fuel cut-off, so there's no CO2 emissions, there's no measurement for us to record. So we get these kind of emission ratios, CO, hydrocarbons, a particle opacity recording, and the wavelength of that opacity instrument broadly gives us a metric kind of PM 2.5 tailpipe emissions. And also kind of, this NO CO2 ratio, and then we apply the FNO2 fractions from kind of latest report from David Carslaw to that data so we can come up with a estimated NOx CO2 ratio. And to estimate emission factors. So these emission factors are a guide to verify, check emission models too. I don't suggest actually using these directly because remote sensing doesn't, for example, isn't a valid recording if vehicles are travelling less than 5 kilometres an hour. So, you know, we don't get this kind of pass-by throughput through the instrument, which is how it works. So, yeah, it's a useful kind of guide to verify emission models. So what we do, we take basically the emission ratio to CO2 for each individual vehicle. We multiply that by its type approval figure, and then we add a correction factor. The latest, I think the latest biggest sample is from this kind of ICCT report. So the difference we see is, so black is diesel, green is petrol, mainly for branding of fuel pumps, but also maybe for air quality pollutants. That colour coding works. So yeah, type approval figures, as we've all seen, fall drastically, and there's this kind of increasing gap. So we're taking account of that, coming up with our kind of estimated emission factors. So this summer, what's been happening? Okay, so this is just the kind of, these box plots kind of show the variation in emission factors, but also the mean, which is obviously important, the solid black line. So petrol, hybrid, as shown many times, petrol cars are clean, really kind of emitting Knox emissions at a low level, Euro 3, Euro 4, three-way catalysts are performing well. And don't seem to be deteriorating too badly. Diesel cars, usual story, fairly flat through the Euro standards up to 5, and we're seeing a roughly 50% reduction for Euro 6, which is, it's not great news, but it's not bad news that there is actually finally a step change reduction. But you're going to learn a little bit more about that. It's maybe not quite as good in the short term as that graph might suggest. So for PM, particle filters are doing their job and emissions are coming down. Euro 5, Euro 6 are both emitting this kind of coarser PM 2.5 fraction at a low level. So that would seem quite good news on the kind of on the Knox side. Could be better. It should be a lot lower, but just unpack that a little bit more by looking at what are the percentage of passenger cars that were registered since September 2014 that are Euro 6, and by manufacturer. And this is quite informative. So Mercedes are leading the way, so we've got both petrol and diesel indicated. So Mercedes, we've been actually seeing Mercedes Euro 6 in our data sets from 2012, 2013. There've been, the initial, maybe more prototype cars, real kind of top end of the price point, have been on the road for quite a few years, and Mercedes are leading the way in as much as more than half of their sales now of diesel cars are Euro 6. So there's still some Euro 5s coming through, even from Mercedes. But most of their petrol cars now being sold are Euro 6. But it's interesting as you go through the manufacturers, and some big manufacturers at this end, we haven't seen any Euro 6 cars on the road. And this actually, kind of reflecting on this a little bit, everyone has got very excited. Let's understand Euro 6. So labs, people doing PEMS testing, they go out and they get whatever cars are available on the market. When maybe the initial excitement of a new Euro standard has passed, some of the other manufacturers have only just started introducing these vehicles. And that kind of the funding isn't there maybe to do the testing of the vehicles with time, so maybe some manufacturers' cars actually haven't been tested by any research groups in Europe in independent laboratories. So that's the case. So whilst it might seem that from September 2014, people are perceiving that all cars will be Euro 6, and that isn't the case. So this 50% reduction is obviously getting significantly watered down because there aren't that many of the new cars actually being Euro 6. And there was actually a message passed round the London Air Pollution Research group recently, just by somebody suggesting that DFT and the VCA have kind of derogated the Euro 6 emission standard, put it back another 12 months. So, which is a bit disappointing because these 50% reductions are going to take a while longer to feed through. But some really good news on the heavy duty vehicle front. So we actually didn't see any Euro 6 buses on the corridors we looked at. I think maybe we picked a different corridor that did have some Euro 6 buses, which are quite rare at this moment in time. We might have looked at some. But these are kind of the NOx CO2 ratios from articulated and rigid trucks. And unlike cars where we've got this 50% reduction roughly, there's nearly a tenfold reduction. So we've got this step change in NOx emissions in urban driving conditions. These are kind of congested urban locations. We've got this massive reduction. And just to kind of corroborate that, there's one publication from Transport for London on the programme of testing they've been doing on Euro 6 vehicles as part of the ultra-low emission zone kind of due diligence work, where they've tested a lot of vehicles, light and heavy duty, over a London drive cycle. So it's been in a lab, but it's a long, very variable speed profile drive cycle representing London driving conditions. A lot of testing data, and I do recommend, there's a lot of kind of, really good, firm evidence in this report. So they've done testing. Loading is also important. So we looked at rigid, two sizes of kind of rigid HGV, either empty or fully laden, and articulated, empty and fully laden. So I haven't made a mistake here. You might be thinking, so if you can make out, so we've got rigid, 0% load, and then a massive reduction, rigid, 100% load. And that's because it is completely against intuition, as many things with NOx and NO2 seem to be. There's this massive reduction because the engines need to be working hard to keep the catalyst and the SCR system hot enough to be effective, and it's this step change. So the remote sensing data's somewhere in between. Vehicles typically running around, you would have thought, I think the DFT figure is, there's a certain amount of empty running. Most vehicles are running around kind of 50%, 50-60% load, quite often limited by the space in the freight vehicle rather than the load that it can carry. Articulated trucks, actually the remote sensing seems to be actually a bit lower than the emission factors from that kind of lab testing. You'd expect actually articulated trucks are more often going to be at capacity than rigid vehicles. So that hopefully this is I think this is really encouraging kind of evidence, and it also demonstrates that it can be done. These emission controls can work in urban driving conditions. Okay, so we're going to move now on to this manufacturer comparison. So there's some results that I've circulated and shown fairly recently. One was the obvious: let's pull out all cars that have this offending EA189 engine. I'm reading today actually in the newspapers that maybe there's another engine that might possibly also have this software on, but they don't know. I cannot believe that they don't have massive teams of software engineers quality checking their code. A big organisation like VW don't have a few programmers working independently and being able to work in a rogue manner. I don't buy that at all. But anyway, that's an aside. So Audi, Seat, Skoda, Volkswagen, all with the same engine. And if you look at kind of the sample size, they're all actually broadly at the same level, which is what you might expect. What's maybe a little bit more surprising is from all other manufacturers, I've labelled the kind of ones, the larger, kind of the ones that we're seeing more vehicles from, BMW, Ford, Kia, Toyota, Vauxhall. How do they compare their 2-litre diesel Euro 5 engines? And they're quite a bit higher, about 25% higher, which is a bit perplexing and might not be what people from reading newspapers might be detecting, but I think those in the know have known this has been happening. And looking at Euro 6, what's the difference kind of Euro 6? And there's a surprising level of conformity across manufacturers. So we've got Audi, Volkswagen, BMW, Mazda and Mercedes. They're the only ones where there's a sufficient sample size to kind of make some form of assessment, and they're broadly at the same level. Now, you might ask, well, is that because of part suppliers, their equipment, Bosch, etc.? There's this kind of that they're using similar technology, or is there some form of agreement to kind of behave in a similar way? Because if one all of a sudden was providing completely clean cars, which actually right now actually could be a good marketing activity, and actually I think that is one way that we could actually affect a much bigger change than this slow moving through the Euro standards. I've got to put petrol on the end just to demonstrate, just in context, how much cleaner petrol cars still are against these latest Euro 6 cars that are cleaner. Now, this is the next graph I'm going to show. To be honest, I'm a little bit nervous about showing this, but this is what the evidence and the numbers show. I've basically looked at the kind of Knox emission factor by manufacturer by year of registration. And broadly speaking, we've got this kind of mess in the middle that all manufacturers all but one seem to be having emissions at a similar level, which that kind of previous graph would show. We've got one over here, kind of older Land Rovers seem to be emitting maybe more NOx. I don't know, when I've been cycling against maybe some of the older Land Rovers, kind of 2000 vintage, maybe I've sensed a little bit of pollution. But the most surprising finding is kind of how different one manufacturer is, which is Vauxhall. So these were kind of 9%, from a kind of significance point of view, these were 9% of the cars that we surveyed. And yeah, basically the contribution from the car fleet, because they're different, is about kind of 5% of the NOx from passenger cars as a kind of total. So that's quite surprising, and I think needs to be looked into. So, yeah, this kind of data, I've been trying to kind of, like many of us, communicate this to the press, and I kind of just brought together some of the evidence. I got the phone call, which I've been getting quite a few. One about the Norway data, is this real? And I made the journalists aware of the TfL data as well. It's kind of in the public domain. This is also what my data shows. It's kind of the slightly ridiculous situation that a small city diesel car is emitting as much as a 40-ton articulated truck driving in central London. And I think that's kind of, yeah, it's good to kind of communicate that to the public, that actually the technology does exist, it's just there's some cost, and either profits need to be sacrificed or customers need to pay slightly more to have cleaner vehicles. So, rather than kind of just having some conclusions, some things I would do if I was in a position of more power rather than just providing evidence. So, yeah, RDE regulations sooner rather than later, and I think the bargaining position of motor manufacturers is slightly weakened in the current climate, so hopefully we will be able to get that through sooner rather than later. Transparency in testing. I have never received any data from the motor industry. There isn't much transparency in testing data, and that is also something that I kind of really encourage, moving towards independent, more open data where we can analyse and critique, because there's little details that the motor manufacturers can pull that can blur figures. And if we had that, there could be some more kind of environmental labelling of vehicles for kind of CO2 and air quality pollutants. And that could be a marketing incentive for suppliers. And I know one of the cars tested by the EPA in the US from BMW was really clean for NOx in challenging driving conditions, so it can be done. Yeah. Shift in the tax landscape. I think many of us are frustrated there's not a lot happening on that front. Price of fuel. Belgium has announced that they're going to put diesel up by 10 cents per litre, at least for 2016 and 2017. VED could reflect air quality pollutants as well. But I think the big one is company car benefit in kind tax that massively encourages the sale of diesel vehicles. Many company schemes are diesel only. You cannot get a petrol car. Even if it was a small little city petrol car, you cannot get one because the company is also exposed to some form of tax around company cars, and they want to keep that as a lower level as possible. But yeah, also around car-free city centres for sustainable mobility, active travel, quality of green space and life. I'm kind of quite excited that, I don't know, many of you have been to Leeds and you've walked out of the railway station and nearly been run over. Hopefully that's going to not be a thing of the past, where that road through the kind of city square is going to be closed. And we also need not forget about kind of noise. I think the impact of noise on people's health is going to come back up the agenda, and this kind of greening and pushing cars further and further out of city centres to make a nicer environment for everyone will have good impacts there. So finally, I am expecting air quality to be improving. I also do lots of kind of vehicle emissions modelling, and my forecasts for kind of up to 2020 are that Knox emissions in kind of urban areas with urban fleets are going to fall somewhere in the region of kind of by 30 to 40%. So finally, we can expect to see a slight decrease in concentrations, hopefully, at our monitors around the country. So, thank you.
Thank you very much for your presentation, and especially also for your good work done. That is very useful for all of us. My question is, I always, when I saw your studies, because I don't understand how you calculate the NOx from the NO2, because you say that only one instrument is measuring NO2, and then Euro 2, Euro 3 has 11% NO, and Euro 6, Euro 5, Euro 4 have 55% NO2. Sorry, 11% NO2 and 55% NO2.
So we're measuring the kind of NOCO2 element, and we know what Euro standard and fuel type that vehicle is. So from these kind of published NO2 fractions, yeah, we can estimate the NO2 element. So yeah, so there's some variation, that is, I'm completely pragmatic, that is a limitation of this kind of approach and instrument, but it's the only one we've got in the UK, and the only research instrument in the world. It's quite expensive to bring it over. It's also quite a lot more kind of temperamental and difficult to operate, and it does have some of its own challenges as well. Okay, so no method is perfect.
Yes, no.
Yeah.
It's excellent results. The issue is that it will be also interesting showing the NO2 emissions, because if you reduce by the half the NOx emissions, but you increase by double the primary NO2, Euro 6 for primary NO2 has not effect compared to the others.
Yeah, so I have done some analysis of that, but as we're just estimating that, I don't think that's kind of should be the core part of the analysis from this instrument. That's more what the analysis of data from this FEAT instrument, and I hope that the UK import, DEFRA, UK PLC, find the finances to bring that instrument back again, because we need that. It's precious evidence on the NO2 front. As more cars with Euro 6 technology from other manufacturers start to hit the roads next summer.
Are you aware of any other countries doing this sort of work?
So Zurich, I've been to the team in Zurich. So it's interesting going to see them. They obviously approach remote sensing in a very Swiss way. So we go and do measurements in an air quality management area, and some cars will be cold starts. Okay? The Swiss go every year, they go to the same place on the same day for the same number of days, and it's up like a 2%, 7-8% rise for 2 kilometres with no roads entering it. So it's not really an urban area at all. It's kind of a very nice green Swiss hillside. And all the vehicles are coming through. The reason is that they're all hot start, because they only want hot start emissions. But actually, you want to just know who's contributing in an air quality management area. You can't estimate. It's very difficult to estimate how many vehicles are cold start. But yeah, they're the only group that have been doing a lot. I know there's a company in Madrid have bought an instrument, and there's a group in Sweden that import an instrument on occasions. And we do share kind of data.